and welcome to the virtual UT Physics Circus. My name is Suzanne, and this is Natalie. We are graduate students and scientists at UT Austin. And we're so excited for you to be here with us today because we're going to show you some really exciting demos about electricity. So to start, let's define what electricity is. Can you point to something in your home that uses electricity? That's right. Actually, you're all using electricity right now to watch this show. So what is electricity? Let's break it down. If you tuned into an earlier show we did, you learned about states of matter. And you learned about how matter is made up of tiny individual components called atoms. Well, electricity is also made up of tiny little components, but we call them charges. And the important thing is that these charges have positive and negative values. You could also call it up and down, green and yellow. The point is that they are different. And opposite charges, what do you think? Do they attract or repel each other? They attract each other. What about the same charges? Do greens like greens or do they want to get away from each other? Like charges repel, so they want to get away from each other. So that's what electricity is made of. Now, let's get down to some cool demos. So I'm going to hand it off to Natalie to kick it off.
Okay, so what can we do with the two types of charges, right? Suzanne told us that we have positive and negative charges, but you can really call them up and down or green and yellow. It really doesn't matter as long as you know that there's two different kinds of charge interactions. So let's think about what might happen, in a thunderstorm in your house, or if it's dry and you run through the house with your woolly socks or something. In both of those scenarios, there's going to be static electricity on various different surfaces. And static electricity just means that that one type of charge is sitting on the surface of an object. So to illustrate kind of what static electricity is, which you may be familiar with already if you've ever zapped yourself on a doorknob after running around in your woolly socks. So to mimic the woolly socks, I've got this rabbit fur here, which is a type of material that can place one type of charge onto one surface. So here I have a plexiglass plastic rod, and this is a very good, what they call an insulator. An insulator likes to prevent charges from moving around too much. So the charges will stay on the surface very well. So what I'm going to do is just rub this plexiglass rod, and I'll show you how we can interact with, hopefully you can see these. These are tinsels. So tinsel is kind of an insulator in itself, but if it's charged, you'll see it interact with. And by the way, today is a very humid day here in Austin, so the environment really affects electricity. So let's see. Maybe they need to be discharged. Okay. So you can just take any holiday tinsel, something off your Christmas tree that you left down there. And let's see. Oh, did you see that jump? Let's try that again. What's happening here? Think about what's happening with the charges. Wow. Okay, so this tinsel is very attracted to this rod. Why is that? Well, when I rub the rabbit fur on the plexiglass rod, I'm placing one type of charge on it, and the other type of charge, the opposite charge, is inside of the tinsel, which is sitting on this table attached to the ground. But tinsel is very light, so it's able to jump through the air. And because they're opposite charges, they attract. And that's why we have tinsel jumping onto this charged plexiglass rod.
All right, so a lot of you might be wondering what this big thing is over here. Now this is what we call a Van de Graaff generator. And what it does is it takes one type of charge and puts it on this big sphere, and it takes another type of charge and puts it on this little sphere. And it does so using this black belt right here. So when I turn it on, it's going to be kind of loud. And then that loud noise is the belt putting one charge on the small sphere and the opposite charge on the big sphere. And what you can do is you can bring the spheres close together, and we're going to turn off the lights, and you're going to look closely and see what happens when we bring these opposite charges close together.
Pretty humid day.
This one.
You can see it, I think. Can you see it? Yeah. Okay.
So if you look closely, you can see little, almost like bolts of lightning going from the little sphere to the big sphere. Now, the sparks were kind of small because, as Natalie said before, today's very humid in Austin. And on humid days, these experiments don't work as well. If it was really dry outside, you could see big sparks going between the two spheres. Now, think about what's actually happening. It looked like lightning, and it actually was very similar to lightning. And when you see a lightning storm, what's happening is the charges are actually jumping in the air from the clouds above to the ground. And you see both light and you hear thunder because there's a large energy discharged when the charges jump to be close to each other. So that's what the Van de Graaff generator simulates. Now, Natalie's going to do another cool experiment using this contraption.
Right, so we saw that because these are two different spheres, they're both, they have their own charges, but because they're opposite charges, they like to jump through the air to be with each other so bad that they release a form of energy in light. So what happens if we have things that are in the same charge instead? So earlier, Suzanne showed us that when you bring together two things of the same charge, like these two green charges here, do you remember what happens when we try to bring them close together? Are they going to attract or repel? Oh, I think they're repellent. They don't want to be close together. So with that in mind, think about what these charges are going to be doing. Okay, these charges are going to be sitting on this metal pie tin here. They're nested together very well because they actually fit together, but they do like each other because they're conductors. So conductors like to share charges, and you can think of them as little green things moving around within this sphere as well. So because they're touching, they're sharing the same charge. Now, what do you think is going to happen when I turn on the Van de Graaff generator? Okay, so keep your hypothesis in mind, and let's try it out. Okay, gotta charge up a little bit. I actually think we might be able to increase the speed of the belt. We have a little tool to do so. Okay, we also have some smaller pie tins. Maybe think about a reason why this might not be working. Okay, so we actually have some small, this, I think you can trim it. So good thing we've got tiny pie tins, and what's the difference between one of these guys and one of these guys? They're identical except for their size, right? So one of them perhaps weighs a little less than the other, and maybe by decreasing the weight of the object, the mass of the object, we can get the electric force to overcome the force that's keeping the pie tins grounded to the ground. Let's just try it out. Maybe something smaller. Maybe fewer tins. So I checked my weather up this morning and it was 93% humidity. So we can always blame the weather on things that don't allow science to work. But if you'd like to check out that demo, we also have YouTube videos in which this did work out. So if you're interested, please feel free to check out the Physics Circus YouTube.
You want to say what would have happened?
Yeah. Okay, so what would have happened is these pipekins would have flown off. Made a big noise. They would have flown off because they were the same charge and like charges repel. So if that was your hypothesis, then you would have been correct if we could have seen that.
But our next demo should actually work. Again, this is a result. If you want to do electricity experiments, make sure it's really dry outside. That's in and of itself an interesting result of science, that sometimes your experiments change depending on the weather. But now what we're going to do is something I bet you never thought was possible. So we're going to show you how you can make a light bulb out of a pickle. So just
every time I'm out of light bulbs, I don't feel like going to the store, but I've got pickles.
Just grab a pickle. So think about how electricity gets delivered to your electronic devices, right? You plug it into the wall, and the electricity, the charges, flow through wires like this. So what we're going to do is we're going to plug this wire into the outlet, and we're going to take these two metal probes, stick them into the edges of a pickle, and we're going to flow charge through the pickle. Now think of a light bulb, okay? When you plug a light bulb in, it glows. What part of the light bulb is causing it to glow? If you thought of the word filament, you're just on target. So inside a light bulb, there's a little filament, and when electricity flows through it, it really heats up, and it emits energy in the form of light. So that's what our pickle is going to do. Is this off?
Yep.
Okay. All right, so we're going to grab, and these, by the way, are ginormous pickles. The biggest I've ever seen. They're also pretty stinky.
Yeah, and then after you use it as a light bulb, you can eat it.
Yeah.
It serves so many purposes.
All right, so I'm going to stick them in there real good.
Sometimes they like to run.
Yeah. All right, we're in there. Now Natalie's going to turn on the power, and let's see what happens.
Okay.
Ready?
Ready, go.
Woo!
Wow! Check out that light bulb!
Whoa.
All right,
All
hands
right.
off.
See, so now you know how to turn a pickle into a light bulb. I wouldn't try this at home, though, because it's very dangerous to play with the electricity that comes out of your outlet. Also, it really stinks.
Yeah, oh my gosh, I can smell it through my mask. Yeah, wow, here it's like really, really strong. So why does a pickle light up like that?
Well, it's because when you try to send electricity through a medium that doesn't conduct electricity well, it causes a lot of resistance. And when you have resistance, like a filament in a light bulb, which is has resistance to electricity, it emits energy in the form of light and heat. And so that's what the pickle was doing. It was the filament resisting the electric current in our light bulb.
Cool, so maybe one day we'll have pickles for filaments in light bulbs. Just things change and there's cool trends going on, so keep an eye out for that one. So the next demo is actually one that you can try yourself at home. It's totally safe. You don't have to plug in a pickle to your wall outlet, and you're not going to risk electrocuting yourself. So if you'd like to follow along with us at home, I suggest you can use the tap water in your faucet in the kitchen sink, but we don't have a faucet here, so I will just demonstrate with some water flowing out of this kettle, okay? So Did you know that you could become a waterbender using electricity? We're gonna take this rabbit fur again. At home, you could use something like wool socks or your carpet, and we're gonna supercharge this balloon. So grab a balloon, grab some socks or some rabbit fur. Hopefully you don't have too much rabbit fur sitting around home, but we're gonna supercharge this balloon, and hopefully it's enough with the sweater. So that looks pretty supercharged, right? All right, so I'll just do that again, and hopefully you can see this water bending. So, okay, this one's gonna need a little bit of a close-up. All right. So let's pour some water. Watch what happens to the stream. Okay, let me charge the balloon again. Did you see that? It's even better if you use it with a faucet because then it's a very steady stream of water and you can definitely see it moving. Okay? Let's try it again. Wow. Look at that water bending. Look at those droplets of water flying around. That's super cool, huh? So why does that happen? Why does water move in an electric, why does water move when it's close to something with charges on it, right? Well, water actually has its own charges in it, which is one reason why you shouldn't dry your hair in the bathtub or do anything with electrical outlets while you're in the shower. Water has these, it's a molecule, hydrogens and oxygens, right? And each of those has their own set of charges that goes along with it. You can learn more about that in our States of Matter show. And when you bring something that's charged close to the water, in this case, it appears that they were oppositely charged because you could see the stream of water kind of flicking towards the balloon. So that's an example of something that you might not know had charges in it. Charges are everywhere. Charges are in all of the matter around us. So yeah.
Yep, and that's the last demo for our show. So now if you have any questions, type them into the chat box and we can answer as best we can. Are there any questions?
There are some comments that the Pickle light bulb is really nice, but unfortunately,
No
somebody sympathized the pickles.
Yeah. Yeah, so think of some questions. We'll hang around for a few minutes. Electricity is a really fun thing to talk about, so no silly questions. You can ask anything you want.
Mm-hmm.
Maybe you can charge it while waiting.
Charge this again
Yeah.
with the questions?
Yeah, just charge it while you can you wait. Maybe you can accumulate more charges.
Maybe, yeah. I'll try the small ones. I think there's a dial in here that you can change the speed of the.
Like do you need the key to switch it to?
It's not like a key thing. It's like you need a wrench.
Is this so?
Oh, I'm just thinking like stick in the hole and then turn it if the key is the right
Yeah.
size.
We used to have one, but.
Here, actually, let me. Oh, you.
I have one. Are there any questions yet?
Wait, sorry. There are questions maybe.
Okay.
Can I do a water bender? Can I be a water bender?
Yes, you can be a
can.
water bender. You can do it.
Can you use any balloon?
Can you
Any
use
balloon?
any balloon?
Yeah,
Yeah.
can I use any type of balloons?
Yeah, anytime. Like if you don't have one of these long balloons, if you just use a regular round balloon, that works too.
We have a very odd shaped balloon here.
Yeah. The important thing is the material that it's made of, not the shape. So as long as you have a balloon that's the normal rubber material, you're good.
And then ask who is behind the camera. I'm behind the camera.
Oh, that's Max.
That's Max behind the camera. Thank you, Max.
Thanks for doing our show, Max.
Yeah, and why the pickle glow yellow?
Oh, that's a good question.
This is a good question.
The pickle looks kind of yellow. I wonder if the pickle was dyed blue, if it would glow blue.
Or there's another possibility is the sodium make it glow yellow.
Yeah.
If you, if that's the thing you can,
Max is gonna
Max
come.
is going to explain sodium.
So you can actually try that at home if you, but use a really long tongue. You can put a salt on your, on a spoon,
Mhm.
and then put it on under the flame. The flame will turn from bluish red to yellow.
Oh, okay. So it's just a property of salt that makes things look yellow.
Maybe that might be the possibility, and also the color of the pickle.
Yeah.
Yeah.
These, I mean, pickles, I usually think of green pickles, but
Yeah,
these
but
are,
they're definitely yellowish.
well, the sodium content is very high. It's, you have 19% of your daily sodium in one pickle. So
Ooh.
that's definitely true. Also, in your street lights, they're yellow sometimes. And I think those are the kind of light material is sodium in those cases, like a sodium gas.
And can you explain the pickle again? How
Yeah.
does it go up?
Yeah, so with the pickle, what we did was we put 2 metal probes into the edge of the pickle, and these metal probes are attached to wires that we plug into the outlet. So when we turn on the outlet, we get electricity from the wall, and the electricity flows through the pickle. Now, there are some materials that are good conductors of electricity and some that aren't so good. And when they aren't so good at conducting electricity, they present a lot of resistance. And that can cause heat and light. This is what happens when in the light bulb, you flow electricity through, and when it hits the filament in the light bulb, that's why it glows. And sometimes your light bulbs get hot to the touch. So that's what's happening here. The pickle itself is causing a lot of resistance, and so it releases heat and light.
If you keep the power on, the pickle all the time, will the whole thing glow?
That's a good question. It does glow like in parts of the pickle. So I think what's happening is, and it always glows very close to the probe. So what's happening is, I think the majority of the energy is getting dissipated right when it hits the pickle. So maybe if you had a smaller pickle, then you'd be able to glow the whole thing. But I think this one is too big, and so all the energy gets dissipated right at the edges. So I don't think we could get the whole thing to glow, unfortunately.
Can you light up other vegetables?
This is a good question. I think the unique things about the pickle are, one, pickles are already kind of translucent. So a potato, for example, wouldn't necessarily glow in the same way. Also, I'm wondering if the fact that it has a lot of sodium is also important here. So maybe other pickled vegetables. So maybe you just have to pickle your vegetables first and then turn them into light bulbs.
And does the water bending has to be hot water, or can it be cold?
Oh, that's a good question. So in this case, I don't know if temperature would affect the charges for those range of temperatures. So if we're just dealing with, cold water that's around the temperature in your fridge and hot water that's like bath water, I don't think you should see a big change, but temperature of water does affect other properties that you can learn about in States of Matter show. We're actually going to do a demo that has to do with temperature of water. So that's a very good question. It's very open-minded. So thank you for asking.
Somebody have a very scientific mind asking what happened if you put a light bulb in the pickle.
Oh,
okay.
So if you put a light bulb that is plugged into the pickle, and if you don't have the probes, then I think you would the pickle would glow. So that's a way. If you cover your light bulbs in pickles, then yes, the pickles will glow with light. It would still be smelly, so I don't recommend it.
I think then we can use that as a factor that maybe we can see that if the color is the same as if you put in a light bulb, and if it's still the same color, or it's actually more yellow, that's basically one variable.
A good test.
Yeah, that's true. You could see how the color changes by you could or stick one of those mini flashlights into the pickle and see what happens.
Okay. Can you use other conductor instead of balloon? Be a water bender, like Lexi?
Plexiglass?
Like this thing?
Yeah, maybe.
Yeah, so balloons and like rubber is actually an insulating material, which is why the charges stick on there like a static electricity. If it was a conductor, then it would just flow from the balloon to my hand to the ground. Because charges like to just get to the ground as fast as possible. That's one thing, because the Earth is very, very big. And in terms of opposite charges, all the charges want to go back to the Earth from the opposite charge. But you could use this plexiglass rod too. We just thought at home you would probably have a balloon instead of a plastic rod, but you can use something else if you'd like. You should test it out yourself.
Is it like a chemical reaction when the pickle glow?
Chemical, they're probably, so this feels like it's outside of my expertise on the subject. I would imagine that there probably is some chemical reactions happening because you're adding a lot of heat to the pickle itself. And of course, everything in the world is made up of chemicals. And so the pickle, and also it's like very juicy, full of water. So you add heat, there's probably some chemical reactions happening. But what you see, that light, that is energy that's being released.
Yes. Why is called physics circus?
Well, so we're physicists, and this whole demo show, which normally when we're not virtual and we're in person, it's a whole hour and we do all kinds of topics, not just electricity. So that's why it's kind of a circus. It's like a big tent full of demos and fun stuff. And it's all physics, so that's why that's our name.
What happened if you use a banana instead of a pickle?
I don't know. I guess bananas aren't as juicy as pickles.
Yeah, bananas, well, they are mostly water, I think, but they're not. The nice thing about pickled things is that they become like kind of that translucent. So I'm sure that there would be some heat energy in the banana. I'm not sure if we would see a glow. That's a really interesting experiment, though.
Yeah.
We should try it.
Yeah, actually, bananas make better hammers than they do light bulbs. So
Yeah.
Would electricity flow through a glass of a plasma ball like it does with a metal globe from SETI?
A plasma ball?
Like a ball that have little spikes.
Oh.
Oh.
So wait, what's the question?
Would the electricity flow through the glass? So basically, are those two analogies like a similar?
Is this the same
The ball, yeah, this metal ball is a similar
Oh.
phenomenon as a plasma
I think
ball.
the thing that's missing in this case is a plasma ball where you have the glass around it. There's some kind of gas inside that it allows you to see kind of the path that electricity is taking or something. It's the plasma, right? It's like,
I would
do you know?
assume.
I'm not sure.
I would.
I'm not sure how those work.
So a few comments.
Maybe it's higher voltage.
So I would assume that is a similar phenomenon, but in the plasma ball is a low pressure, so that the charge have a basically imagine this in the air is a crowded street, you cannot move as fast. But in the middle of nowhere, basically in the desert, the charge can move much faster, so that the plasma ball can move more freely like a fluid, and also looks prettier because it uses certain gas that you can see the discharge in the different color, in the more colorful color. And then for the banana, I was thinking, if we use a higher voltage, maybe we can have
Hey, but this is already pretty high.
Yeah, no, this is actually, well, this is the input voltage, but I think it gets like 10,000 volts or something. But the thing is, well, electricity has all kind of fun properties, but you can actually touch this. I'm not gonna do it today because I don't feel like accidentally hurting myself. I wasn't prepared for that. But some of my friends with short hair, they can stand on a crate, isolate themselves from the ground, and touch the ball and put themselves at 10,000 volts, and their hair sticks out. The tricky part is getting back on the ground, because you have to jump from 10,000 to 0, but anyway, that's for another time. We'll let you move on to your other Girl Day activities, so thank you all for all the wonderful questions, and thanks for tuning in.
Bye, thank
Bye,
you.
guys.
Yes, so I